Hello, dear friends, welcome back to Math with Amala. This is the part 8 of grade 12, chapter 1 Relations and Functions. Now we are moving to the second part of exercise 1.2, seventh question. It is given like f from R to R defined by f of x equal to 3 minus 4x, and you have to check whether it is 1 1 or 1 2. It is 1 1 because f of x1 equal to f of x2 implies x1 equal to x2, hence it is 1 1. Now let's take f of x equal to 3 minus 4x and y is equal to 3 minus 4x. Then x is equal to y plus 3 divided by minus 4. Now you can write f of x, y minus 3 by minus 4, then that is equal to 3 minus y by 4. You can cancel negative from both numerator and denominator. Now what will be y? That is f of x, that is f of 3 minus y by 4. That is, you can give like 3 minus 4 into 3 minus y by 4, which means we are substituting this value in the f of x function. That is equal to 3 minus 3 plus y. So you're getting f of x is equal to y. Hence we can say it is an onto function because there is a pre-image for every element in the codomain. Now we can say that the first function is bijective since it is both 1 1 and onto. Let's write f from R to R defined by f of x equal to 1 plus x square. Now let's check the bijectiveness of this function. F of x1 is equal to 1 plus x1 square. F of x2 is equal to 1 plus x2 square. Now you can equate them. You can cancel the 1s. x1 square is equal to x2 square. This condition is not true since minus 2 square and 2 square are 4, but minus 2 is not equal to 4. So it's clear that it is not 1 1 because we are having a same image for two elements from the domain set. Now let's check the ontoness. Let's write f of x equal to 1 plus x square. That is, y is equal to 1 plus x square. Now you can write x square is equal to y minus 1. That implies x equal to plus or minus root of y minus 1. Now x value takes two values, positive and negative root of y minus 1. Now let's find the value of root of y minus 1 when we give the function. That is 1 plus root of y minus 1, the whole square. Then you will get 1 plus y minus 1, that is y. Okay, so you are getting it as onto for this root of y minus 1. The negative side also will remain with the same value y because we are taking the square of the negative in the function. Move to the 8th question. Let a and b be sets show that f from a cross b to b cross a such that f of ab is equal to ba is bijective function. Now we can write f of a1 b1 is equal to f of a2 b2. This is the supposition. Then b1 a1 is equal to b2 a2. This implies that b1 equal to b2 and a1 equal to a2 because they are positioned in that way. Now let's take a1 b1 is equal to a2 b2. We have got here a1 b1 equal to a2 b2. Hence it is an injective function or it's a 1 1 function. For the next, let's take b comma a belonging to b cross a. This implies that a comma b belongs to a cross b because these are particularly taken from small b is taken from capital B, small a is taken from capital A. Hence a cross b will have this image or pre-image which is a surjective condition. Hence it is an onto condition. Next one, 9th. Let f from n to n be defined by f of x equal to n plus 1 by 2 if n is odd, n by 2 if n is even. For all n belongs to capital N. State whether the function f is bijective, justify your answer. Here f of 1 is equal to 1 plus 1 by 2 because it is an odd number. So you can take the first value, then that is 1. F of 2 is equal to 2 by 2, that is again 1. Here f of 1 and f of 2 are 1, but 1 is not equal to 2, hence it is not 1 1. Okay, so f of x1 equal to f of x2 doesn't imply that x1 equal to x2. Now let's check the case of when n is odd. When n is odd, you will get n is equal to 2k plus 1. Let's because the n will be of the form 2k plus 1 for any sum k belongs to R. F of 4k plus 1 will be equal to 4k plus 1 by 2, that is 2k plus 1. That is the n that we have taken. If n is even, it will be of the form 2k. So if we take f of 4k, then you can put that in the function and you will get 4k by 2, that is 2k, which means we are getting an onto function. Hence this is not a bijective function since only ontoness is holding here. Oneness is not holding, injectiveness is not there. 10th question, let a is equal to r minus at 3, b is equal to r minus at 1. Consider the function f from a to b defined by f of x equal to x minus 2 by x minus 3. Is f 1, 1 and onto? Justify your answer. F of x is equal to x minus 2 by x minus 3. F of y is equal to f of y can be defined with y minus 2 by y minus 3. If we suppose f of x equal to f of y, this implies x minus 2 by x minus 3 is equal to y minus 2 by y minus 3. Now you can cross multiply. X minus 2 is equal to y minus 3. X minus 2 into y minus 3 is equal to y minus 2 into x minus 3. Xy minus 3x minus 2y plus 6 equal to xy minus 3y minus 2x plus 6. You can cancel xy's on both sides. The remaining will be, and also 6 also can be cancelled. Minus 3x minus 2y is equal to minus 3y minus 2x. Now you can cancel all the negativeness, or you can take the negative outside. 3x plus 2y is equal to 3y plus 2x. Now you can group the x terms together and y terms together. You will get 3x minus 2x is equal to 3y minus 2y. That implies x equal to y. This implies this function is 1, 1. Now you can check the ontoness. Like let's take f of x is equal to x minus 2 divided by x minus 3. Then y is equal to this f of x. So y can be written like x minus 2 by x minus 3. This implies y of x minus 3 is equal to x minus 2. That is xy minus 3y is equal to x minus 2. Here you can write xy minus x is equal to minus 2 plus 3y. By grouping x terms and y terms together, you will get x into y minus 1 is equal to 3y minus 2. That is x equal to 3y minus 2 divided by y minus 1. Now let's write f of x equal to f of 3y minus 2 by y minus 1. You can put this in the function 3y minus 2 by y minus 1 minus 2 divided by 3y minus 2 by y minus 1 minus 3. Now you can do the multiplications, cross multiplication for the subtraction of the fractions. Here you can write 3y minus 2 minus 2 into y minus 1 divided by 3y minus 2 minus 3 into y minus 1. You can cancel y minus 1 on both denominators because they are similar. Here you can open the brackets and you will get 3y minus 2 is minus 2y plus 2 divided by 3y minus 2 minus 3y plus 2. 3y minus 2y, y minus 2 plus 2, 0. 3y minus 3y, 0. Minus 2 plus 3, 1. Then your answer is y by 1, that is y. Hence it is an onto function. So simply we can say this is a bijective function since it is both injective and surjective. 1, 1 and onto. Question number 11 says like let f from R to R be defined as f of x equal to x raised to 4. Choose the correct answer. Two variables can be taken here, x and y. X raised to 4 is equal to y raised to 4. This implies that x is not equal to y because it's not possible for any x and y. Thus it is not 1, 1. Now let's write f of x equal to x raised to 4. Then y is equal to x raised to 4. Y is equal to x raised to 4. Then x is equal to y raised to 1 by 4. The fourth root of y is x, or plus or minus y raised to 1 by 4. Then f of y raised to 1 by 4 is equal to y, since f of minus 1 by 4 is equal to minus y. Hence you are getting different values. Hence it is not onto. Since this function doesn't move to a particular y only. Hence the option D is right. F is neither 1, 1 nor onto. 12th question, f from R to R defined as f of x equal to 3x. Choose the correct answer. F of x equal to 3x. 3x. You can write f of x1 and f of x2, or f of x and f of y. 3x equal to 3y. Then x equal to y. Hence it is 1, 1. You can cancel the 3's very simply. Then it is 1, 1. Now f of x equal to 3x. and x equal to y by 3. F of y by 3 is equal to 3 into y by 3, that is y itself. You have got it is like on 2. Hence, the option A is right. F is 1 1 and on 2. Thank you all for watching the video. Please be stay tuned for the next part.